Okay, today we're going to be learning about transformations and congruent figures. There are two things that we want to accomplish today. First thing is we're going to be determining corresponding parts of congruent figures. And the second thing we'll do is determine the type of transformation or transformations. We might use more than one. Determine what kind of transformation we use to create the congruent figure. I want to remind you that congruent figures can only be made with these three transformations. We can only make them with translations, which is sliding a figure, reflections, which is flipping a figure, and rotations, which is turning a figure. Remember, we can't make congruent figures with dilations. So for example, if you had a multiple choice question that was read something like this: triangle ABC is congruent to triangle A prime, B prime, C prime, what transformations were used to create A prime, B prime, C prime? And your choices are A, a reflection and dilation, B, reflection, rotation, C, rotation and dilation, or D, reflection and translation. Well, you automatically know that two of these choices we can eliminate because two of the choices say dilation, and we can't create congruent figures with dilations. Remember, dilations make figures smaller or bigger. So those two choices are automatically gone. So then we can just look at our graph over here, and we can tell that they must have flipped triangle ABC across the y-axis to get it to be backwards, or a mirror image. So it definitely had to be a reflection across the y-axis. And then remember, rotation means turn, and it doesn't look like that figure was turned. It just was slid down after they reflected it across the y-axis. So the answer here would be D, a reflection and a translation. So if you'll take a look at your notes page, we're going to start down here with example number 2. So it says triangle ABC is congruent to triangle XYZ. Write congruent statements comparing the corresponding parts. Remember, I said that's the first thing that we're going to be doing today, is comparing the corresponding parts. Then the second thing we're going to do is determine what kind of transformations happen between ABC and XYZ. So to write the congruent statements comparing the corresponding parts, it's important that you really don't want to look at the picture to be able to do this. The easiest way to write your corresponding parts is to look at the directions. So if we take a look at our directions here, we can see that A is the first letter in the first triangle, and X is the first letter in the second triangle. So angle A is congruent to angle X. Then I just keep going. B is the second letter, Y is the second letter, so angle B is congruent to angle Y. And then do the third letter. C is congruent to Z. So those are your corresponding angles. Those are your angles that are going to be congruent to each other. Then for the corresponding sides, you're going to do the same thing, except it takes 2 points to make a side. So the first 2 points are AB, and the first 2 letters in the second triangle are XY. So AB is congruent to XY. Then do your second and third letter. BC is congruent to YZ. And then you're going to have to, because a triangle has 3 sides, you're going to have to do the last letter in the first letter. So CA is congruent to last letter, first letter is ZX. So that's how you determine which angles and which sides are congruent to each other. Then the second thing we want to do is figure out what they did to be able to get ABC on top of XYZ? Well, AC has to land on top of XZ. AC has to land on top of XZ. So they had to flip AC over the y-axis. Now if I flip ABC over the y-axis, it's going to be, there's where A would land, and then B would land here, and then C would land there. So just flipping it over doesn't line it up with XYZ. So not only do we have to flip it over, then we've got to move it. And remember, moving is called a translation. And if we just move it 2 units down, it will be right on top of XYZ. So ABC was reflected over the y-axis and translated 2 units down. And that's how it landed, and they call that mapping on top of XYZ. Okay, let's look at this next one on part B here. We've got 2 parallelograms, and this one's a little tricky, so it's really important that you look at the letters in the directions. WXYZ and KLMN. I know that angle W is congruent to angle K, and I know that angle X is congruent to angle L. Remember, I'm just going by my letters, not really looking at the picture. And I know angle Y, since it's the 3rd letter, is congruent to angle M. And angle Z is congruent to angle N. And then let's do the sides. So the sides, I know that WX is congruent to KL. And I know that XY, because it's the 2nd and 3rd letter, is congruent to LM, because it's the 2nd and 3rd letter on the other parallelogram. And then I know YZ is congruent to MN. And then I know that that's only 3 sides. Remember, I've got 4 sides here. So the last thing I have to do is the last letter and the first letter. So I'm going to do ZW is congruent to NK. Now, especially these sides are going to be really important when we try to figure out what kind of transformations happened between WXYZ and KLMN. I know that WX has got to land on top of KL. Well, here's WX, and down here is KL, and W's got to land on top of K, because that's the angles that need to land on top of each other. Well, W is on the right side, and so is K. So, but the problem is K's on the bottom of the parallelogram and W's on the top. So I've got to get W to the bottom of this parallelogram. And the only way to do that is to flip WXYZ over. So if we flip WXYZ over across the x-axis, then I think we'll have it where we want it. So if I flip W across the x-axis, it's going to be 3 down instead of 3 up. So that's going to make W right here, 3 down. That's going to be W. And then Z will be right there. And then Y, if we flip it over the x-axis, is going to be there. And then X will be right here. So now it's flipped correctly because WX and KL are the same way now. And so now I've got to just slide that over to the left so that WXYZ lands on top of KLMN. So I just need to count now how far I have to slide it over. So I want Y to land on top of M. So let's just count how far over it is. So it would just be 1, 2, 3, 4, 5 to the left. So this was a reflection over the x-axis, and a translation 5 units left. 5 units left. Okay, our last example, number 3. Molly is using a brace to support a tabletop. In the figure, BCE is congruent to GFG. If the angle CEB, so we're talking about this angle right here, is 50 degrees, what's the measure of angle FGD? FGD, we're talking about this angle right here. Well, I know from the congruent statement that they give me, I know that angle E is congruent to angle G. So if angle E is 50 degrees, then that means angle G is also 50 degrees. So that's the missing angle measurement. If you look at part C, it says the length of CE is 2 feet. And they want to know what's the length of FG. Well, if I go back to, again, to my congruent statement, I can tell that CE, those two letters, would be equal to FG. So that means FG also has to be 2 feet. So at this point, I want you to try the 3 problems at the bottom of the page. When you're finished with those, raise your hand and let me check those, and then you can start on your homework for tonight.